Alrighty, thanks for coming. Hopefully, small enough group, we can keep this kind of interactive if you want. If you've got any questions as we go along the way, just raise your hand. I'll try and see you through the spotlight. If not, like maybe wave it. Try and not make this too much of a presentation kind of a thing. So at Google, I work on the Chrome team, technically. My part-time, what I also work on is WebpageTest, if you're familiar with it, web performance testing. And the two work really well together because usually when I see things going slowly in WebpageTest, I can go, well, why the hell's Chrome doing that? And I can actually go fix it. So hopefully I can talk to a little of both. If you made it to Human's talk a little bit earlier, he talked a little bit about synthetic and RUM testing. So this is for actively testing the performance of your sites. WebpageTest is an example of a synthetic testing platform. You've got a test machine sitting somewhere. It goes ahead and tests the website, goes out, through the cloud, the internet, all that kind of stuff. Hits the CDN server, the web server pulls down the content. That's certainly not an authoritative or complete list of testing providers, but pretty much everyone on there does that kind of testing. If you're using Keynote or Gomez for your performance testing, you're largely doing synthetic, even though they do offer some RUM performance testing. Historically, so my history before going to Google, I spent like 11 years, I guess, at AOL doing random performance stuff. A big part of it was also performance measurement. And we were both a Keynote and a Gomez customer, and we tracked our performance metrics as this is the load time in Keynote at this quarter. We set alarms and all that kind of stuff. And one of the big issues you get into when you start optimizing for that kind of stuff is, so here I called it gaming. Maybe we'll just call it optimizing for the metrics. But so we go in to do like a CDN eval, for example, and it turns out that some of the CDNs knew all of the Keynote and Gomez edge nodes and knew where they were, and they went ahead and they put their edge nodes in the same racks as the test machines. So we'd end up in a situation where we're doing our performance tests against the sites, and we're pulling down all of the static content from the CDN. We're doing the eval, and all of a sudden, hey, this CDN looks like it's twice as fast as all the other CDNs. Let's go with them. And since we're using the Keynote and Gomez metrics for our KPIs and our bonuses, guess which one we pick, right? Hey, this one's faster, and now we're stuck with them because we can't go to anyone else, even though technically they're a better deployment, because we're tracking everything based on the test measurements that are measured from right next to where the CDN staged their edge nodes. And I was going to say, it's not necessarily the CDN's fault, because they knew what metrics we were trying to optimize for, and they optimized for the same metrics, right? So you want to be really careful about what you're measuring and how you're measuring it. So that's why sort of over the last few years, RUM, real user measurements, sort of been taking off, if you would. It's always been around. Yahoo, I think, was probably one of the first ones that started doing it, where you measure the performance of your real users from the browsers, and you report back what the real user experience is. There's sort of two variations on this. There's probably more. Two in the web world that I spend most of my time in, the APM side of things, application performance management. The New Relics, the app dynamics, they sit on the servers, they measure the performance of the back-end application largely, and they'll also do some front-end performance. Front-end, we usually refer to all the crap that happens in the browser once you've delivered the HTML out. Historically, all that crap is usually about 90% of the page load time, whereas about 10% of it's spent back on the back end doing server time in aggregate. That said, if you've got a case where the server's taking 10 seconds to serve a page, please go fix that. And don't even bother looking at the front end until all that's under control. But once the back ends are performing well, APM works really well for tuning, figuring out what are your slow queries, what are your slow services, that kind of stuff, and for optimizing. But where you really want to spend all of your time focused on the end user experience for performance is usually on the front end from the browser's perspective in the case of web pages. There's a fair number of companies. SOSTA, they bought a company called LogNormal, which is sort of founded by Buddy Brewer and Philip Sosta and a few others, the guys that created Boomerang from their work at Yahoo. So it's kind of got a long history of end-user performance measurement from the browser. They're kind of the leaders in that space. Most of the synthetic companies are also offering solutions in that space to give you an idea of what the performance is from the browser's perspective, from the user perspective. That said, they all still largely report the same things. I guess I have some pretty graphs and screenshots. This is usually what an APM looks like. On the top left, you sort of have the trends breaking down. This is New Relic's view of, this is actually the WebpageTest web server's view of the APM, the backend. Pretty much all of the time is spent in PHP because it's a PHP app. It'll give you a breakdown by technology, how slow is it. I think my response times are under 20 milliseconds, so I don't really have a lot of optimization focus going on there. SSDs for the world. Artur, thank you. Although more interestingly, and this is generally the case where you'll want to pay your attention, is the histograms, the breakouts. The averages don't really tell you a whole lot. It's the ones that take 200 milliseconds, 300 milliseconds, what's going on with those, and figure out what needs to be done to optimize those. In my case, I do some video rendering on the server. That's going to take a while. I've kicked it off to be async, so known issue. I've accepted it. More interestingly for me, this is the run perspective. This is what SOSTA's dashboard looks like, for example. They also give you largely percentiles. I think these might be the 95th percentile times over time. And you can see globally from where the users are visiting, where the performance is bad, where it's good. You set your thresholds. But even in this case, it's largely, so right front center, they've got page load, 3.24 seconds. What does that actually mean? For my users, it doesn't really mean a whole lot. There are a few ads on the page, a few other things, but that's not necessarily measuring the user experience. And that's largely what I wanted to talk to you guys about. But really quick, take a slight side tangent. When you're measuring the real user measurement, largely that ends up being instrument your code with JavaScript, report it up to a server somewhere, and get pretty graphs and result data. And for a lot of these things, what you usually end up wanting to do is dump them into a beacon. So you'll create an AJAX request that goes up to your server or something that has a whole bunch of query parameters for all of the different things you want to measure. You'll send it up in a beacon, log it into an access log for hitting it, and you get all sorts of cool stuff for free. Right? You get when it happened, where it came from, if you're doing reverse lookups on the IP addresses. Also the ISP that it came from, the operating system and the browser that was used, all that comes from the user agent string. If it was a mobile device, and what page they were browsing when they got it. So you get all this stuff for free in the access logs, and then you just add all of the measurements that you care about on top of that. And then all of a sudden, you've got a fairly rich measurement platform. You can roll your own at that point. You don't necessarily need one of the commercial providers. Sort of down at the bottom is a free open source sort of pipeline of what that might look like. You sort of take the access logs, dump it into Logster, aggregate those into statsd, create graphite graphs off of those, put them in Grafana. Whew, you've got dashboards. I'd say roughly half of the companies in the lobby would also be more than happy to take that data that you're pumping into your access logs and give you something useful to do with it. Because the first thing you're going to notice when you're looking at RUM data is it's noisy, like really, really noisy. And if you want to make useful decisions out of it, you need to sort of start breaking it down and go, okay, was it IE users in China now that are having a problem? Or what caused this spike here? Is it because there were only 5 users browsing the site at 2 a.m.? That kind of thing. And so beyond just doing basic graphs, you're probably going to need a whole lot of data filtering and ability to drill down into the metrics. And that's where, go out, talk to the guys in the lobby. They'll be more than happy to do that kind of stuff for you or pipe your stuff. But you can sort of get your feet wet just dumping the pipeline into your own graphs. I've been going fairly quick. Everyone still with me? No one's asleep after lunch? Alrighty. So kind of got onto it a little earlier about gaming the metrics or optimizing for the metrics. The page load time is probably the worst metric that you can use. I mean, maybe 5 years ago it was semi-relevant. It was largely the time when all of the content that the user cared about loading. Since then, we've added a whole lot of ads, we've added a whole lot of beacons, we've added a whole lot of trackers. Stuff that may not actually impact the user experience is all getting loaded. So technically, the page load time is the point in time when everything that was defined in the HTML has been finished, parsed, and loaded by the browser. And then the browser will fire the onload event, done. It can still be doing a whole bunch of Ajax JavaScript stuff. Any iframes that we're loading would be completely loaded, but it can be loading all sorts of stuff below the fold. It could be firing tracking beacons to say, hey, 20 ad providers that have tags that I must instrument my pages with, this user visited, this user visited. And you'll end up with waterfalls that sort of have a very steep initial load, and then this long tail of stuff that just kind of fires all sorts of third-party stuff. And all of that, your onload doesn't fire until the end of that, even though your user content may have loaded much, much, much earlier. So what absolute best gold standard for what to instrument is if you have a user action, something that the user actually came to your page to do, instrument that. Put in a JavaScript beacon that'll track when that actually got parsed is largely the best place you can do for it. If you have a hero image, a really good technique for that is to add an onload handler to the image tag. And then you can track when, hey, this is when the hero image loaded. So if you've got an article page, for example, you can track both when the hero image loaded, when the text was parsed, maybe fire the later of the two or fire both independently. And you've got all of a sudden the point when my article was displayed to the user. That's an important metric. If someone games that metric, great. They've made the experience better for your users, right? If they do it by deferring ads and somehow the ads had an impact, okay, now you've got a reason. If, on the other hand, you're using the onload metric, you may end up in a situation where you go, hey, ads have this long tail of chained requests. They load the ad.js, then they'll make the call to get the actual creative, but that call ends up getting redirected to a third party and then redirected to a fourth party. And then you have the ad asset, which then loads God knows what, and it's pushing my onload out. And if you're being held to the load time for your page, you're going to go and see, you're going to go through a waterfall and go, hey, the thing that's pushing out my onload is this ad. Let's get rid of the ads. Great, you've just gotten rid of all of your revenue. No problems. And the user experience may not have actually gotten any better, because if the ads were actually implemented in a way that they're loading asynchronously, you could actually load the ad without impacting the content. So you're making really bad technical and bad business decisions. If, on the other hand, the ad was loaded in a blocking fashion so that your content doesn't load until the ad does its document.write and all sorts of other evil things to your page, in that case, if you're actually tracking the content that you care about, you can see, hey, we made this ad async. All of a sudden, our content is now loading a lot sooner. You still have your revenue, and you've got a much better user experience. So if you take anything away from this talk at all, and I hope maybe you pull little nuggets, the one thing you take is measure what you want to improve, and make sure you're measuring it from the situation you want to improve. So in this case, measure it from the actual user browsers, track that as your KPIs, track that as, or push back on the business side if they're telling you we want performance metrics to track. Make sure that you're pushing back that they're tracking the right ones, because otherwise you're going to be making bad decisions. Sort of one other example Human had earlier in his talk, and this will sort of counter some of what he was trying to promote for, but he had the case that, a 10 millisecond and a 25 millisecond round trip time to a CDN maybe doesn't impact the page load performance at all, and that's not what you should be making your decisions based on. Or you shouldn't be making the decisions based on the synthetic testing of those. I'd actually counter that if your real user metrics are showing no difference between those, then maybe the CDN is not a decision that matters. Pick one for other business reasons. This one has lower costs, or this one integrates better with our tech stack, but the performance, at least in a lot of testing that I've done for, so WebpageTest runs on a bunch of different CDNs. Largely, anytime I switch a CDN, they generally have, in aggregate, equivalent performance for hot static items that don't change. My business metrics, the stuff that I track for when users visit, doesn't change between them. However, the technology and what you can do with each one of them is vastly different. But I certainly wouldn't, if I was testing it with synthetic tests like Keynote or something, my results would be very different. And sort of along those same lines in the gaming the metrics, he also had a chart showing sort of the Sodexis ranking of CDNs. You can get it off of the Sodexis site, and they have sort of the 95th percentile and the medians. One of the other things that ends up causing a problem is if you don't measure the performance based on the actual traffic visiting your actual site. So like Sodexis tests a well-known static object of theirs. It's known that maybe some CDNs have optimized for that one well-known static object and have it cached in RAM on their edge nodes, whereas your static objects that are in your long tail for your contents that are being served are not. So you have to be really careful whenever you design an experiment that's synthetically testing or evaluating these kinds of things. If you start hitting one page or one object and pulling that one consistently, it's going to behave very differently than your actual page content, which may have a long tail of images or a long tail of something else, or may have JavaScript that has nice long cache headers and is always coming out of the browser cache and is never being served from the edge, right? So you have to be really careful when you're doing these sort of synthetic evaluations. That's why, when possible, if you can generate enough traffic, just measuring your actual content, maybe doing an A/B and splitting some of your content off to serve live traffic from the evaluation you're doing is really the right way to do it. That said, a lot of data is usually the problem because RUM data is really, really noisy. Unfortunately, users have highly varying connections, and they don't all browse consistently at the same time all the time. As far as the browsers go, a few things when we're sort of talking about rolling our own performance metrics, a few things that the browsers have recently started exposing, and by recently, this one's probably 3 years old at this point, I think, navigation timing. There's a few specs. There's a W3C working group on performance. It's an open public list. I highly encourage participating in it, especially if you're a content producer and want to get information out. It's largely the browser guys talking amongst themselves, inventing stuff, assuming they know what people would want to consume. The more of you that actually participate and say, no, this is what we want to consume and this is why we want to consume it, the more likely we are to build stuff that you care about. That said, I think this one and most of these tend to fall into the stuff that we've been begging for a long time. Navigation time is a window.performance object on the DOM that the browser exposes and gives you all sorts of information about the page that you just loaded. And the most important thing, so a lot of these things, it gives you markers for when the page started loading, when the content started coming down, when DOM content ready fired, when onload fired. A lot of those stuff was available before. People used to just do a date.now when the DOM content ready event fired or when the onload event fired. The big revolution in what it gave you is it gave you all of the timings for everything that happened before the first byte of your page came down, before any JavaScript could run. So now the things that I think, at least from an ops perspective, that are really interesting is you get the DNS time that was spent by your browsers for every user that visited your site. And if you want to evaluate the impact or how your DNS performance is doing, don't test it synthetically. Measure it, report it. You can get the DNS time for every user that ever visited your site. You can see how effective your TTL caching strategies are. Same thing for the TCP socket connect time and the first byte time talking to the server. Now, largely the first byte time you can sort of get from your APM. You can get the amount of time that was responsible, your servers were responsible for that time. But from the browser perspective, you can also get the ISP's impact, the last mile impact on that kind of stuff. That's sort of where really the interesting stuff to me is that stuff that comes early on. I don't know, unfortunately it doesn't break SSL negotiation out separately. That all sort of gets included and lumped into the connection time. That's something probably to be aware of as you're tuning and optimizing as you're moving, because everyone is moving to SSL, right? And HTTP2. As you're doing that, there's a lot of work that needs to be done to tune that right, to optimally get into the one round trip time for SSL negotiation. OCSP stapling, some of the things you want to avoid having to do cert verification checks out of band. So if you start getting long TCP connect times in the field, that's one of those things where you have to start digging in with other tools to figure out, okay, what about is it our TCP or is it our SSL stack that's not tuned quite well for delivery? Resource timing, this is even more recent. It largely gives you all of the same information except for every request that fired during your page load. So after the page loads, you can do window.performance.getEntries by type, get entries by name, or just get entries. And it'll give you detailed timing information for every resource that loaded during your page load. There is a slight caveat. Anything that comes, you'll get start and end times for everything, as well as the URL that was requested. If you want the granular DNS, TCP connect time, first byte time, and content downloaded for the individual requests, it either needs to be from the same origin, or the server needs to respond with a timing allow origin. I usually just do star, and encourage you to use that header for any content that goes through your CDN as well, so you can see the performance timings. You want to be, that's a lot of data. So I don't know that you necessarily want to, let's say on average, you've got 150 requests on your pages. I know some of you are worse than that, some may be better, but you don't necessarily want to be beaconing up performance data for 150 requests. So you're going to want to figure out what is the logic that you want to apply. Do you do some aggregation on the browser side? Do you go, okay, these are my CDN domains. Let me report the minimum, median, and highest time during this page load for resources from the CDN. Do you want to report the number of third-party domains that were called? Do you want to have a whitelist of third-party domains that you know about and report any third-party domains that were called that you don't know about, for example? It will only provide information for requests that were loaded as part of your document. The reason I sort of draw that line is iframes are where things, especially as we start talking about ads, iframes are where things get a little more interesting because iframes are their own document, so you won't see the timing for resources or even the details about resources that load within the iframe. If it's a friendly iframe and you can access it, you can also reach into the iframe and get its performance timing data, which you might be able to do for ads, which usually load in a friendly iframe form. Although, like the Facebook like button, the Google +1 button, some of those load iframes for authentication information and don't allow you to reach in and get their timing information. But sort of if you're doing the audit of what did my page load, what didn't it load, just know that you're restricted to see stuff that's not within iframes, for example. And also, because I'm probably giving Human nightmares, before you go complain, sorry, by the way, Human right there is from Fastly and CDN land. But before you go complaining to your CDN that the performance looks bad, just realize that when you're loading resources in the wild in real browsers, they're loading in parallel with a whole bunch of other stuff. More often than I really care to admit, I get people asking me about waterfalls, wondering, why is this one resource, it's an 8K image, why is it taking 3 seconds to download? Is there a problem with my CDN? Or worse yet, they've already opened a ticket with the CDN. And then I have to look at the waterfall and go, well, it's because of the 200 megabytes of other stuff that you're trying to download at the same time. and it's competing for bandwidth. So just realize that none of these individual requests are operating in isolation. They're operating within the context of your page. If you happen to have some JavaScript that fires and does a blocking operation in the middle of one of these things loading, and it runs for 3 seconds, you know, the browser's not going to read the resource while you're doing that. So a lot of this stuff can impact your timing. So just be careful before you go pointing fingers, and do a bunch of investigation and get a bunch more supporting data, and go before you go, hey, all of a sudden our CDN's taking 10 times as long to load. Packet captures. Everyone believes packet captures. So if you can reproduce it in a lab environment, grab a packet dump, then send that over. There are a few other specs coming, and they're in flight. These definitely, if you're interested in, please participate. Network error logging. The specs I gave you so far largely only get reported when things are successful. They loaded my page. This is the timing that's available. These resources did load. These are the timings for them. In the cases where the page did not load, it failed, that's where network error logging comes in. And it won't work on like someone's first visit to your page, but on subsequent visits, in the first visit, you can provide some header information that says where the browser should beacon failure information to. And then at some point in the future, if the user tries to visit your page and it fails, the browser will, in the background on its own, send a beacon off to the other server that you told it about and provide the failure information. So you can start tracking failure navigations as well. And that way you can start getting into the availability reporting from real user monitoring as well. And that's important mostly because when you do your synthetic testing, and you're doing it for availability testing, yeah, you can place nodes globally on, let's say, 10 different ISPs in 3 different locations or whatever. But you'll never be able to get 100% coverage. And the amount of stuff that breaks out in the wild, peering, CDN issues with like one ISP in one country with one edge node, there's a lot of that stuff that goes on, and you won't have visibility into that until either your users complain or you start getting beacon data back for. The other one is server timing. Most of the APM guys have sort of their own solutions for this, where they inject their own IDs into beacons or stuff, but this will sort of give you an easier roll your own solution. What that does is on any HTTP response, you can add a bunch of headers that have sort of opaque information. Largely, it's supposed to be numeric, I believe, and the browser will just make it available to JavaScript. So in theory, you can provide timing information about this is how long the database calls took, this is how long it took me to call out to this third-party service on the back end. Include that in your HTTP response headers. And then the JavaScript, when it reports the timings for the overall page, it can also go and pull the server timings and give you sort of the granular data. Like I said, there's nothing in the spec that requires it to be timing. They're just numeric. And that was done so that, for example, if you're going through a CDN, the CDN can also include which edge node ID was used or some things like that. So you can do other diagnostic information in there as well. And then presumably you'll do something interesting with it and beacon it back. Really quick before I completely jump topics, are we good on the measurement side of things? And everyone is going to start measuring user experience now, right? Uh-oh. Is the beacon spec still a thing? Yes, sorry, I didn't include it here. So the beacon spec was largely more for, like, you can use it for performance as well, but it's a way for you to tell the browser, send this request. I don't care about knowing that it completed. I just want you to make sure that it completes. And the main reason for that is analytics pings and things like that. Usually analytics companies would add an on-unload handler and prevent the page from navigating away until they can guarantee that the beacon went out to the server to track the user. And this was a way to do it more asynchronously. That's actually shipped in browsers. So if you are implementing your own performance beacon, it's a good way to do it. Although I generally encourage you instead of waiting until the user's about to navigate away and firing your beacon then, and you'll probably want to include things like how long were they on the page and how much of this video did they watch and stuff like that. If you can get your performance stuff as early as you can measure it and then beacon that out, you're more likely to get more complete measurements. I'm not saying that the beacon doesn't always work. I'm just not guaranteeing that it always does. So the sooner, like right after onload, if onload is one of the things you want to measure, maybe collect everything that you care about and report it then. The other thing to watch out for is the resource timing, where it gives you the timing information for all of the requests that your page loaded, has a buffer. And I think the default buffer size is 150 requests, which, depending on your page, may or may not be enough. If early enough, you can adjust that buffer size, or you can request that buffer be increased. You can also set on buffer full events or something like that, so you get notified when it's about to run out of space. If you actually want to know about all of the requests and your pages generate more than 150 requests, you're going to want to collect that information before the buffer fills up. Otherwise, you're going to start losing stuff. Or people are going to wonder, and your metrics are going to track, hey, you know, we were increasing, but we've held the line at 150 requests. We're doing awesome. And it's just because, you know, the browser stopped recording things. All right, so front-end SPOFs, single point of failures. We usually know about back-end failures pretty quickly. Our availability testing goes down, we get alerts, our servers stop getting load, that kind of stuff. And all sorts of alarm bells go off. And so one of the things I've been talking about probably for the last year or two is the same thing can happen on the front end, and you're completely oblivious to it. And that's largely because of third parties. Technically, it can be because of you or because of CDN things. Usually, it's because of third parties. The way HTML works and the way browsers work is anything that is defined in the head, the browser needs to parse, execute, and finish loading and apply before it can go on and continue parsing the HTML document. That's a little not entirely accurate, but scripts, if they're not async scripts, for example, are definitely, the browser will reach the script tag, it will stop until that script is available, and then it will continue. We've got a whole bunch of technology in the browsers to predict what else might be needed in the document and fetch those, but what actually gets displayed to the user stops as soon as it hits that script tag. CSS, technically the browser can parse past that, but it can't display anything to the user until that CSS has been fetched and applied. So those are the two sort of big likely offenders. There could potentially be some others, but it's not unusual to see, and unfortunately, it's still not unusual to see blocking script tags for third-party analytics, content trackers. A/B testing is sort of the really big one because they need to decide what they're going to do to your page before the page gets displayed to the user. So those are usually guaranteed to be blocking calls. In this case, so I'm using the US Digital Service page as an example. It's actually, I think it's running on the White House's digital publishing platform, and they inherited some things. And one of the things they inherited was a blocking add this widget, which is actually not displayed anywhere on the page. But conveniently, it's loaded in the head. And they're also loading some fonts from typography.com. And we'll see how well the video works. But so what happens is when add this or typography go down, this is actually, well, go ahead. Woohoo, it's loading. So the actual page and how it loads, it normally loads great on the left. If either one of them is down, the users get a blank page. Your servers, they're still responding great. All of your monitoring is saying, hey, everything's working great. The users, not so much. And if they're really, really patient, somewhere around here, the page will start loading. And this is actually a best case scenario. Windows has a 20-second timeout. What's really happening here is socket connect times out. And that's usually the failure mode when a service goes down, is the servers just become unresponsive. You can't connect to them anymore. It's not a fast fail thing. The packets just go into the ether and nothing's responding to them anymore. The browsers, interestingly enough, don't have their own logic around when to decide we're going to bail on these objects. They try their hardest to fetch the resources you've asked them to fetch. And so they use, all of them use the OS default timeouts for socket connects, for example. And Windows, the default is, or actually Windows, the setting is 20 seconds. So if the server's unavailable, it will time out for 20 seconds. Like I said, this is actually a best case. Mac, Linux, which also means iOS and Android, are 60 seconds. So your users will be staring at a blank page for 60 seconds in that case. And if you didn't think it was down at 20 seconds, by the time you reach 60 seconds, you've navigated away, you've given up, and you've gone on to your next search result. So, oh. It's 20 seconds per domain. It's not necessarily serialized in that, since, like I said, the browsers all have look-ahead parsers, so we generally know if the things are defined in the HTML, we're going to try and open up connections to as many of them as possible as soon as possible. So even if you have like two scripts staggered on top of each other, and they're both down, instead of being 40 seconds, the browser may have already tried opening up connections to both of those in parallel. I say may just because we all have logic about how many resources we're going to load at a time, even if they're across multiple domains. In Chrome, for example, if one of those script tags was down in the body but still before your actual content, we might actually not start requesting that resource until after we've gotten past the head, and we don't predictively establish the connections either. So there are situations where they may get cascaded one on top of the other. In the case of an ad, for example, or if it's something being document.written or injected by script where the browser can't see it in its preload scanner, then yes, those are definitely one right after the other. And in these cases, it may also not be 100% outage. So you could be losing some percentage of your traffic. Oh, so this is another one. Healthcare.gov, sort of our other fun one to always pick on because they haven't had enough pain in the past couple of years. They're using Optimizely for an A/B testing platform. Generally, if you've ever used Optimizely, it will always be a blocking tag in the head, largely because that's how they do their A/B decisions. And if Optimizely ever goes down, you largely see what we just saw with USDSS. It's not a 100% thing. And so this was a real tweet, probably not too long ago, where one of the CDNs was having edge node issues with just one ISP in England. And they're like, yeah, okay, so all of a sudden everyone who had blocking JS that was being served from that CDN for users that were on that ISP, the pages were unavailable. And it's not unusual. So I've got some friends in the UK who do web performance development. Andy Davies, if you don't follow him, he does a lot of tweeting about, hey, it looks like this font server's down because I can't browse anything today, for example. Or more recently, nexus.inciton.com. I'm not entirely sure what they do, but I know they either do A/B testing or something very similar, because they're always a blocking script in the head as well. They're served from one EC2 location, not CDN served. And we all know EC2 never goes down, right? So these things happen in the wild. They're going to happen to you. You just want to make sure that you're aware of that possibility and test for it, and make sure it doesn't block your page. So if the A/B testing isn't, so A/B is a little harder, but certainly add this, and especially if you're not actually using it on your page anywhere, just remove it. But if you really do need any of that kind of stuff, try and make sure it's as asynchronous as possible. Most of them have async widgets or async code for injecting. There are a couple of decent ways to test for it. Spofomatic. This is sort of, back from my AOL days, I had a whole line of Omatic tools. So I kind of resurrected it. It's a Chrome plugin, which while you're browsing the web, it just kind of sits. You have a little icon on the top of the browser. And as you're browsing the web, it'll tell you how many spoofs are on the pages that you're on, or how many likely spoofs. And it'll give you information about what they are, how much of the page content they're likely to block. And you can also simulate. You can say, OK, go ahead and black hole the domains that are likely SPOFs, and then browse interactively and see what the impact is. Also on WebpageTest, you can block entire domains. If you get a chance, I highly recommend just do one load of your page in WebpageTest, see what the third-party domains are, take all of those domains, drop them into the SPOF box, and do another run. When you run a SPOF test on WebpageTest, it's automatically going to run 2 tests for you. It's going to run a not blocked and a black holed version, or I guess I call them original and SPOF. And it'll give you a side-by-side comparison immediately, so you don't have to do anything else to get the videos to show people why it's a really bad idea. And just see. And if you see that you start getting 20-second timeouts, then you're going to have to do some, OK, which one of the third parties is it, or is it all of them, and which one's causing the pain? But you really want to get into a situation where you can dump all of your third parties in there, and the user experience still looks fine. That said, your metrics, if you're tracking the on-load time, are still going to look like crap. And that's why on-load or page load time is still a horrible metric, is even if you're doing everything to make sure none of these third-party analytics or anything else are blocking the user content, they're still going to block the on-load event. And you can end up in a situation where your on-load all of a sudden goes up to 30 seconds, and everyone's browsing the site, and hey, it looks fine. So something's wrong. It's not user impacting, certainly not nearly as bad as if it was blocking user content. Okay. Questions? Because I am about to completely jump the shark and talk about something not measurement related. Here and then.
You mentioned asynchronous JavaScript. Is there something in the HTML that you look at that tells you that whether it's async or not, or is it a matter of what the JavaScript library?
So the question was async JavaScript. Is there something you look at in the HTML or not, or is it library specific? So there are a few things that you can look for. Pretty much, if it's a script tag that has an external source, like script source equals blah, the only way for it to be async is if it literally says async or defer on the script tag. Otherwise, the browser is going to block on that script. There are a couple of other ways to do async scripts. If you have a script injection technique, which creates a script element in JavaScript and appends it to the DOM, that's sort of the classic way to do async JavaScript. If you append JavaScript to the DOM through JavaScript, it will be async as well and not blocking. Whereas if you document.write, it will be completely blocking. And then if you're using a script loader to say, hey, like, I forget which ones, but something.require, and then you give it the JS. Most of those will take care of loading those asynchronously and doing it in the right order. The biggest thing you want to look out for is just script tag, source, and no async or defer tags on them. And those are guaranteed to be blocking. And, yep.
So you talked a lot about like when you have a single point of failure and you have spots in your production site and you're testing for those after the site is up and running. Do you have any advice for code coverage that tests against like introducing those? I mean, I guess you can always just sort of test what's in the head, but.
Okay, so the question was, is there a way to catch them before they go to production, basically, potential SPOFs? So, I mean, you can take the SPOF-O-Matic code is up on GitHub. And, I mean, the logic is fairly easy to parse the HTML and look for script tags. And the only things it's really looking for is, are there script tags that are not async or defer and that are not from an origin that we control? The logic for origin that we control in SPOF-O-Matic is a little more complicated than it probably needs to be for something where you own the CDNs. And so you can just say, hey, are there any script tags like in the first half of the HTML that are coming from a third party that have async or don't have async or defer? And that would be a fairly easy filter to write for catching it early. You could also, in theory, test it. And actually, if you can get the code up on a staging server and it's calling all of the domains, you could basically black hole anything that's not from one of the origins that you control. Although just scanning the content is probably an easier way to do it. Yes?
Is there a way to get an insight into actual script performance?
Is there a way to get insight into actual script performance? So participate in the W3C working group list. There was a debugging spec. I don't know if it was called debugging or something. It's been tossed around, which was largely to get some visibility into some of that. There are a couple of things. So DOM content, anything that's attached to DOM content loaded or the onload event, you can get a duration for both of those from the navigation timing. So you can see how long did my page spend executing scripts in either one of those handlers. As far as details into why or what's going on, without instrumenting the code, not currently. They were trying to toss around, so the guys from Dynatrace were working on trying to push away, since they largely do that kind of thing. They were trying to push away to get that kind of information and visibility from the browsers in RUM. It's been bandied about for maybe 3 years, though, so I don't know if I'd hold my breath. Unfortunately, sorry. All right, so onto the resiliency side of things. Anyone here familiar with service workers? They're the new hotness in browser land. And they're sort of the table stakes for being able to do some new technologies like navigations from the browser pages, or notifications, OS integrated notifications from browser pages and stuff like that. But let me see, I thought I had there we go. So technology-wise, what a service worker is it sits in, at least in Chrome, which is the only launched implementation I'm aware of. Firefox has committed to it, and I think IE is also looking into it. It sits between the browser renderer, if you would, and the networking stack before it actually goes out to the network. And it's JavaScript programmable. You get to see every network request that's coming out from your page. And you can do all sorts of really cool and crazy shit with them. You can reply with your own completely synthetic responses. You can manipulate the request before it goes out on the wire. And once you have sort of those basic capabilities, you're a proxy in the browser that you control entirely. I will say it's HTTPS only. Largely because you don't want to accidentally pick up someone else's man-in-the-middle for your pages as you're browsing random access points.
How is U defined exactly?
So U is defined, I may have a page on this, but U is defined exactly as, so this is what a service worker registration looks like. In the HTML for the page, it will register a path to the service worker code, which needs to be served from the same domain as the document. That said, that JavaScript can then pull in resources from almost any other domain that it wants to pull in from. It is assuming a secure connection to the origin over HTTPS. That's not always the case. Enterprise certs, man-in-the-middles in corporate environments, that kind of stuff. But it is what it is. It's not as bad as it might sound. But yes, trust me, the security researchers are spending all sorts of time going, oh my God, this is going to be fun. Let's start looking for exploits now. Yeah, although, I mean, I don't know. So as far as the service worker itself is concerned, so as far as what you can do with SPOFs and things like that, it gives you a lot of power. In creating its own SPOFs, I don't know that it would be a new, well, there's a lot of responsibility on the person who created the service worker not to screw up the service worker, because the amount of damage they can do is pretty significant. We'll go there. But assuming the code is working well, it can do lots of really cool things. One of the things that you can maybe play with, so they won't help out with first navigations because you have to register them when someone actually visits your page. But subsequent navigations, you can do your own. So you also see, not only do you see the request for every resource on your page, you see your requests, you see third-party requests, you also see the navigations for the main resource for the page. So once it's registered, it sees every navigation request for any document, including the base document. And so you can do things like, okay, let me go try and fetch the document from the network. Oh, that didn't work. Let me go do a couple of tests. And instead of relying on the browser's snap or some other error page, you can put up your own, you can reply to the browser with an HTML that has your own message that says, hey, it looks like EC2 is down right now. We're working on it. We'll let you know, or try again later, or it looks like your internet connection's down. You can do your own custom error logic and do your own friendly error pages. You can also report when these things happen. So you can keep track of, hey, it looks like our servers were down for 3 requests that this user tried to do at this time, that kind of thing. On the SPOF side of things, the optimistic side of me is you can use it for SPOF prevention, and you can see, hey, okay, these requests went out. They're for a third-party resource. I don't necessarily care or know what they are, but they're not something I can control. Maybe you fire those requests off, and you set a timer, and after 3 seconds, and that's being generous, you go, you know what? No, we'll fail that request. Browser, just go on and go to the next thing that you are going to do. And so you can do all sorts of logic like that and decide what your failover strategy is going to be on the client side. So logic that you're used to doing on the server with load balancers and all that kind of stuff, sort of make the mental adjustment that, hey, I can now do all of this stuff in the browser as well and include the ISP and the CDNs and everything else in my load balancing and failover logic. Yeah, so fonts, that's an easy one, right? Most of them have a failback and just go, hey, you know what? No, we'll cache it. Maybe you complete the request in the background and you cache it locally. And if the browser asks for it later, it's available, but you don't give it a whole lot of time while it's blocking your page from actually loading. Stale while revalidate is another spec that's in flight. I'm not sure if you're familiar with it, but instead of an expires, it lets you go, hey, you know what? Go ahead and always use this resource out of your browser cache, but after a day or so, just check with me and see if I have a newer version. Don't block the load, just sometime in the background check. You can implement that yourself entirely in service workers without the browsers having to do anything. You keep your local version of the cache, you reply with it immediately, and asynchronously you go out and check and see, hey, is there a newer version of this? And it's not only your resources, right? Google Analytics, if it's being called from your page, you can go, you know what? I'm going to always use the cached version of Google Analytics and serve this back right away. And in the meantime, so you can stale while revalidate third-party resources, whether or not the third party cooperates. Maybe that was a bad one, because you don't want to do that with, Google's really good about serving caching. Delta compression, that's another huge one that people have been asking for. So like VCDiff compression or custom compression schemes for delivering Delta updates for JavaScript libraries in particular. You change one function, maybe you don't want to deliver the whole thing again. You can build your own custom Delta compression logic entirely in the service workers, your own validation checks, and you can say, hey, I've got version 3 of this. Give me either a newer version of it or the delta between version 3 and whatever you've currently got, and apply your own delta compression as it's going. You don't have to wait for the browsers to do anything. Test, see what works well. If something works really well, maybe push it and the browsers will adopt it as a spec. But you can also do application-specific logic. You're no longer stuck with sort of the browsers and what we build that fits the best for most people. The new compression algorithms, I will caveat that whatever you're running in a service worker is running in JavaScript. So you probably want to be a little careful about how much logic you actually build and run in the service worker and make sure you're not making things worse. So building entire compression algorithms in the JavaScript and having to deliver it may not be a good decision, but it's something you can play with. Like I said, even metrics and debugging, you can even just pass everything through and capture the timings or the failure rates on stuff and start reporting that kind of stuff. So that's largely, this is the area that I'm really excited about, sort of network geek background. The kinds of stuff that you can do with service workers, they're insanely powerful. And with that comes lots of cool opportunities, although lots of really scary things as well. The service workers, just a quick caveat, because of the likelihood that they, done wrong, you can break, let's say you throw an exception by accident in your fetch path, and now all of a sudden nothing will fetch from your domain, right? The service workers, regardless of whatever cache settings you have from them, the browsers will always check against the origin every day. So worst case, you'll kill yourself for a day, which may still be a big deal, but it's at least not a permanent failure. Whereas if you had pushed a bad service worker and the browser had cached it forever, you could have just taken yourself completely offline, right? Okay, yeah. Actually, that's, like I said, so that's sort of the end of my slides, so we can jump into, I'm sure no one's got questions about service workers, right? So how does that work for iframes? So iframes, iframes are their own documents. So your service worker won't be able to see requests coming from an iframe. If you own the content of the iframe, it will, I'm pretty sure it's the main resource for the iframe. You'll want to check on that. Where it gets a little complicated is if you have iframes that are document.written to have data URI sources, I'm not entirely sure you can even do service workers for those today, because those don't really have an origin. Those have a, hey, I wrote the document in from my page. And there's definitely, it's evolving. It's been in Chrome stable for probably 2 releases now, but even then it's sort of evolved and the capabilities have evolved. You can debug the service workers in Chrome's dev tools, but certainly if you're experimenting with them, please provide feedback. Open bugs, especially if there's anything that you see or any edge cases, like the iframe, especially the domainless iframes, are sort of one of those things that I don't think they've solved yet or figured out how they want to do yet. And they are coming in Firefox, I know that for sure. And I do know, so in case you're sort of worried about the scale, I do know Facebook, for example, recently launched service workers largely for the integration with Android notifications so that they can get native Android notifications. And to do those, you need service workers. So you can sort of incrementally figure out and play with where you want to get your exposure as you build them out. Google PageSpeed, is that a reliable benchmark? So the PageSpeed name is unfortunately heavily overloaded. There's PageSpeed Insights, which I think you might be talking about, which is the grading one, and then there's mod PageSpeed and the deprecated, or the now decommissioned PageSpeed service, which was the will proxy your site for you CDN. PageSpeed Insights is not actually a benchmark. It doesn't give you any timing information, for example. It largely tries to gauge how well you're doing against some best practices. I think it's an interesting tool to give you a list of things that maybe you want to check and take a look at. I highly discourage trying to get 100% on page speed because you can get a good score and do bad things for your site. I highly recommend optimizing for the user experience and having a list of things that are worth looking at to see, are these really a problem or not? And for that, it's really good for. But definitely don't go, oh my God, my page speed score dropped by 3 points or whatever. You want to focus on the user experience and use it as a tool to gauge, hey, am I doing a good job optimizing in general? All right, I'll be here at the conference, so feel free to grab me in corners or wherever and chat more. Thanks.